One of the most important concepts in natural gas processing is the concept of pressure. Your book talks about pressure starting on page 3. In understanding pressure, it's important to understand the difference between force and pressure. Force is actually a component of pressure. But if you start by considering force, it helps you to understand what we're talking about when we say pressure. And you need to be sure you understand the difference and use these terms properly. Force and pressure are not the same thing. The best way to visualize force is by thinking about weight. For example, a person who weighs 150 pounds, they apply a force to where they're standing of 150 pounds. Force is measured in pounds. Of course, that can be written different ways. Pressure is actually defined as force per unit area. Pressure is how much force is applied over a specific area, and it's measured in pounds per square inch. Now, there are other ways to measure it. This is the common way of measuring pressure in the oil field and in other applications. And of course, that can be written PSI. And the PSI comes from pounds per square inch. PSI. Now, in comparing pressure and force, I think one of the best ways to visualize it is if you go back and consider something that we're all familiar with. A person who weighs 100 pounds exerts 100 pounds of force on the ground when they stand. If you want to compare that to pressure, you can look at the effect of that force over a certain area. If you imagine someone stepping on your foot, when someone steps on your foot, they just step on the top part of your foot. If you want to figure out how much pressure is applied to the top of your foot when someone who weighs 100 pounds steps on it, you have to know what is this area, because remember, pressure is force per area. Now, we can estimate that area at, say, 4 inches squared, the area on the top of your foot where someone would step. To calculate the pressure of 100 pounds over a 4-inch area, 4-inch square area, you just write down the definition of pressure. Pressure is force per area. And you just plug in the numbers. The force is 100 pounds. 100 pounds. The area is 4 inches squared. If you do the math on that, it's 25 pounds per inches squared, which can also be written 25 psi. It's 100 pounds applied over 4 inches squared. It's 25 pounds per square inch. Now, what if you imagine you have a person, same person, who's wearing high heel shoes? We're going to decrease the area that same force is applied over. Now, if you get small high heel shoes, that's a very small area on the bottom of that heel. It might be maybe 1/4 of an inch squared. So we're going to say the area is 1/4 of an inch squared that we're going to apply that force over. So is that going to be more or less pressure? It's the same amount of force, but the surface area over which that force is applied is different. So if you do the math on that, pressure is equal to 100 pounds divided by 1/4 of a square inch. If you do the math on that, you get 400 psi. That's a big difference compared to 25 psi. And it goes back to the difference in surface area. Now, I think most of us have had someone step on our foot. Some of us have had someone step on our foot with a high heel, and we can attest to the fact that a high heel hurts a whole lot more than a regular shoe like a tennis shoe or a loafer or something. The difference is not necessarily the weight of the person. The difference is the area over which that force is applied, which comes back to pressure. So, be sure you understand the difference between force and pressure. You need to use these terms properly. If it's PSI that you're talking about, It's pressure. If it's force, that's just weight. And also be sure you understand the actual mathematical equation. And this does go back to math. Math is just a way of representing the relationships in the real world. And what we just showed here is if you keep the force the same and decrease the area over which it's applied, the pressure is increased. And that's because in this mathematical equation, when we decrease the area from 4 inches squared to 1/4 of an inch squared, we decrease this denominator in this equation, which of course makes this overall side get bigger, which makes that side get bigger. So pressure is directly related to force. It's inversely related to area. As area over which force is applied increases, the pressure decreases. You need to understand what's going on there.